Okay, so today we have three panelists joining us. I'm gonna briefly introduce them, and then we will start the first bit. Each of them gonna present the tasks they think would foster creativity in mathematics. Okay, just want to hope there's no problem. Okay, so we have Demetra Pitta-Pantazi today. She's a professor of mathematics education at the University of Cyprus. She has participated in a number of research projects funded by the European Union, the Cyprus Research Foundation, and the University of Cyprus. She was one of the members of the National Committee for the Reform of Mathematics Curriculum for grades K to 12. And she's a scientific advisor for the development of mathematics textbooks used in all public primary schools in Cyprus. Mark Applebaum is the author of 16 books and over 80 papers published in scientific journals and conference proceedings in English, Hebrew, Russian, Spanish, Arabic, Ukrainian, and Polish. His research interests include the popularization of mathematics, teaching mathematics to mathematical promising students, developing creative and critical thinking, and STEM education. Since 2013, Applebaum has served as the CEO of the Kangaroo Israel contest. Viktor Freiman is a professor of mathematics education at the University of Moncton. His research focuses on mathematical creativity and giftedness, problem solving, use of technology, digital competences, interdisciplinary and transdisciplinary connection, innovations, and history. He's currently the president of the International Group for Mathematical Creativity and Giftedness. Welcome, you all. We could have perhaps Demetra start first, and then Mark, and then Viktor go the last, if that's okay.
Okay, thank you very much. Good morning, everyone. And I would really like to thank Dr. Kidiyan and Dr. Amy Mamolo for this invitation. And it's a great pleasure to be able to participate in this Maths Education Forum. I will first start by saying that I think the biggest challenge in the field of mathematical creativity is actually this development of environments, pedagogies, practices, and activities that can foster creativity. And I think one of the reasons for this is that mathematical I seem not to be able to manipulate my presentation. Amy and Kitty, I don't seem to be able to change the slides on my presentation.
Oh, I said it's your...
Yeah, that shouldn't be the case. Did you have multiple screen on? And
can we try again? I'll give it another try.
If that doesn't work, we can screen share from our end.
Yes, I think it's okay. Okay, nice. Yes, thank you very much. Thank you very much. Great. So sorry about that. So as I was saying that, I think one of the reasons that it's so difficult to develop tasks is that we need a common language and an understanding of what are the skills that may develop this mathematical creativity. So recently, OECD suggested that there may be some sub-skills to develop this mathematical creativity. And as Boris was saying earlier, probably it's too complex to think of the whole thing of creativity at once, and we might need some parts of that. So some skills that may be the ones that will help us to develop creativity. So OECD suggested that we need to be able to give children the opportunity or the students to inquire, to imagine, to do things and to reflect on things in order to develop their creativity. So today, what I will try to do here is offer a repertoire of different tasks that have been suggested by a number of researchers in maths education of how to develop mathematical creativity. For example, Rosa Lakin, who has been doing an excellent work on mathematical creativity for many years now, has recently worked on a project, the MathKey tasks, where she talks about the potential of developing mathematical creativity through multiple outcome tasks, multiple solution strategy tasks, combination of these two, and also by giving students the possibility to start from an open beginning and open ending problems. For example, problem posing task where there is an open beginning and probably an open end there. And also through mathematical investigations, which again may be a bit open beginning, open end. But at the same time, apart from all these activities where we have multiple solutions, multiple strategies, open scenarios, I feel that there is also a need to give students the opportunity to experience this aha moment, this eureka moment, when they identify connections between different mathematical ideas, when they are experiencing and they imagining different possibilities. So there are also tasks where we can enhance mathematical creativity by giving students the possibility to experience these aha moments, like the work that Peter Lilienthal had been doing, Leonie Burton, and so on. So today I will start and just demonstrate a few of these examples. So if we take one of the examples Rosa Lakin is providing for multiple outcome tasks, she gave this simple example. Which n-corner polygons can be constructed from two squares? So you may think about it for a few minutes, but of course, with our students, we need to give them more time. And the more time you have, the more possibilities you may think of how to respond to these questions. So once somebody started thinking about it, they may think, okay, I can put one square next to the other, but then there's also the possibility of overlapping squares. So if we see here, if students spend some time on this problem, they may discover various possibilities. There may be various outcomes. I can have a rectangle or I can have a pentagon, a hexagon, heptagon, and so on. And then there are possibilities where the students need to think and reflect on it. Is it possible to have 12 corners? Why isn't it possible to have 14 corners? And they need to imagine if this is possible and reflect on their responses. Another similar task from Halo. Can you create as many shapes as possible with 2 square centimeters? Just use straight lines. Which are these shapes? Again, it appears like a simple task, but students will engage in it in trying to imagine how they can construct the shapes. And they may immediately think of a rectangle, but if they spend more time on it, there are different possibilities. So again, we may have various outcomes. And some of these outcomes may be more rare. And there we say, okay, this child may have greater creativity since they can imagine something that the other students were not able to think of. It can be, again, a very simple task like this one. Separate the rectangle in 5 equal pieces. And then students can give various answers. So the message I want to get across here is that if we want to encourage creativity in our classroom, we shouldn't be looking for this one extraordinary task, but give students the possibility to engage with this activity frequently in the classroom. So let's move on, for example, in multiple strategies tasks. We very often have tasks like this one, continue the pattern. But what if we change the question a little bit and just say, how did you see this pattern growing? How did you imagine it growing? Can you give me a few strategies of how this is growing? Then students may be looking at it like squares falling from the top, or a line appearing at the bottom, or like a volcano erupting, or they may even imagine it like squares numbers by rearranging the squares. So all these are different strategies. We may ask students, for example, to create the number 100 using only the digit 2 and the operations plus, minus, multiply, divide, and exponentation. How can I make 100 just using 2 and these operations? And then we can ask students to try and do it with as few tools as possible. So again, you ask students to use multiple strategies and be creative about it. Now, let's move about to questions that may give students this aha experience, this eureka experience. We often ask students to just compare fractions and find the largest or the smallest. So what do the students usually do? They look at the fractions and they try to calculate the common denominator. But if we change the task and give them something like this, what will students do then? It's a bit complicated to try and find the same denominator. They may start thinking, okay, what if I try to see what makes a whole? How much do I need to add to make into a whole? And they need to progress on this idea. They need to try it out. They need to do something with this. And then they probably think of a creative way of actually comparing it. What will be a smart way of comparing it? Try possibly to have the same numerator. Will this idea come into mind? Again, we give products to students. But what if we change a little bit the question and not simply ask how much does 23 times 35 makes, but actually ask students, since you know this product, come and tell me what else do you know? Can you give me various ideas of what you know? And play with the ideas, find different ideas. So they can think of many different ideas. Another possibility, we may ask students to find in which figure is the black path the shortest. Looking at this task, of course, there is one answer, but they have to find this solution. What do they need to do here? Probably they may start thinking, oh, I have to find the circumference. How do I find the circumference of the circles? This is what I know from maths. But what if they start thinking, is there an easiest way of doing it? Can I take the risk and try a different approach? Can I look at these shapes differently? Some students actually thought, well, I will not think about the circumference, but I will start thinking of how many times I go up and down until I go to the end point. And another student just simply said, well, basically you're telling me to go from one corner to the other, and the idea is for me, which one looks more like a straight line? So they are taking this opportunity, they take a bit of a risk, they work more intuitively, and they look just for the straight line, nothing about circumferences here. So that might be creativity again. And now let's look at this question. Which fraction of the regular octagon is shaded red? By looking at the shape, we ask students basically to try and figure out how to solve it. It's not very helpful if I just look at this shape. I may need to do something on the shape. I may have to imagine the shape being a bit different. So trying to imagine and change this shape and visualize it differently, I may come up with different solutions. So again, some of the solutions that students gave, well, it wasn't easy to think about A, C, B, but I know the answer of A, O, B is 1/8. And what does this triangle have? Oh, it has double the height. So since it's double the height and the same base, that makes double the area. So you need to find like creative ideas, and you may ask students again, give me another answer and another answer. But is this experience of imagining the shape in a different form? What about this? What fraction is the image that is shaded black? If students start thinking about it, that I have a quarter and a 16th and a 1/64, well, it's complicated. Can I imagine this figure differently? Can I have a creative idea on this? Well, if I don't think about the whole square and I look at it like an L shape and think of this part as an L shape and an L shape and an L shape, then the answer might come to me that, well, it's 1/3. So basically there, I gave you a selection again of activities that give you this aha, eureka experience. And as I said before, we also have some problems with an open beginning and probably an open end. Problem posing task. Show them a newspaper and just tell them, create 3 problems based on these articles. Give them an equation. What problem can you think of? Give them different settings, different probes to create problems. And another point, lastly, that I want to make is that we can use our everyday problems and modify them. Our textbooks are full of problems with a lot of information, all the information being given out, a shape giving all the information by the side, and then step-by-step different questions until you answer the most complicated question. So for example, here we present a problem. We say the Louvre, it's a glass pyramid. This is the base, this is the height, this is the slant height. What is the area of the triangular face? What is the total surface area? How much will it cost to clean it if every square meter costs $8? But what if we take information out? What if we don't write the dimensions and the child has to think about it? What if we remove some of the steps and the child has to figure out how will I respond to this third question? Or what if we make the problem even more ill-defined? And we start saying, well, the Louvre is a pyramid and you want to clean it, how much will it cost? Then the children may have to actually solve this problem and address it like a modeling problem or a mathematics outside the world or a problem where I'm missing some of the steps. So all these are different scenarios that we can offer to the students. So coming back to where I started from, I hope that I was able to share with you just some ideas, a repertoire of activities, which I think will give our students the possibility to inquire, to imagine, to do, and reflect on things. And I think that this is what we need to do in the classroom, just give plenty of opportunity to students to engage with problems that will enhance mathematical creativity. Thank you so much.
Thank you so much, Demetra. We have a quick question about this framework. Jimmy asked, is there a related paper or further readings that discuss this type of ways to classifying tasks?
Well, to be honest, I put this presentation together just for the forum, but you can find parts of these things. I mean, for the multiple outcome, multiple solution tasks, problem posing tasks, and mathematical investigations, and this classification, there is an excellent chapter by Rosa Laking. I can provide you with the literature on that. There are plenty of references about the AHA activities by Peter Lilienthal and other people. Problem Posing and Creativity by Kaye, Silver, many people who wrote about that, but not the way I presented it. And also, I shouldn't fail mentioning, OECD has written a lot about this framework, about inquiring, imagining, doing, and reflecting, and they've carried out research of how you can implement that in the classroom. So basically, I have gathered pieces from various areas and put this presentation. I haven't presented this before as a whole, but I would be happy to share the literature that I have used today and give you all the complete references.
Okay, thank you very much.
First, I'd like to thank to Kitty and to Ami for the invitation to participate in this panel and to meet my colleagues, at least in Zoom. So thank you, Kitty and Ami. I'll start with challenging tasks. And this is the plan for my short speech. In my research with Professor Lakin in 2014, we explored the preferences of math teachers and students regarding different types of mathematical challenges. Our findings revealed a clear preference for puzzles over other types of tasks. This preference is not surprising. Puzzles naturally engage learners by sparking curiosity, intuition, and deep analytical thinking. Unlike routine exercises that follow a fixed procedure, puzzles encourage play, discovery, and intellectual challenge, making them a highly effective tool for learning mathematics. Puzzles do more than just engage students. They play a crucial role in fostering mathematical creativity. Puzzles-based learning, we call PBL. It's a little bit confused because PBL is project-based learning, problem-based learning, and puzzles-based learning. All of them are PBL. I'm talking about puzzles-based learning. That is not something new in our practice. So puzzles-based learning directly supports this process by engaging students in open-ended tasks that require them to explore multiple solutions, question assumptions, and make unaccepted mathematical connections. One of the most fascinating aspects of puzzles is the ability to trigger what Faulkner et al. In 2009 called the Eureka factor, that Boris called to them flash of creativity. We are talking about these moments of sudden insight that arise after sustained cognitive engagement. Mikhailevich in 2014 pointed out that unlike traditional problem solving, which often depends on memorized formulas and fixed algorithms, puzzle solving encourages experimentation, reflection, and refinement of reasoning. By integrating puzzle-based learning in mathematical education, particularly in teacher preparation, we equip future educators with tools to inspire creativity in their students. In my recent work with Professor Freiman, that will have his next presentation, we found that prospective teachers not only approached puzzles in different ways, but also actively posed new problems and engaged enthusiastically in discussions. This process of extending and transforming mathematical challenges illustrates how puzzles encourage learners to think beyond predefined structures and develop their own mathematical inquiries. When incorporating puzzles into education, we can take two didactical approaches. One is connecting the puzzles to learned material. And the second one is using puzzles unrelated to learned material. By me, I favor the second approach. I use puzzles that are not directly related to the material being learned at the same time, encouraging students to rely on intuition, pattern recognition, and creative reasoning rather than memorized techniques. A particular category of puzzles includes those that create a cognitive gap, where the mathematical tools required for solving them are accessible even for 8 or 9 years old students, yet the level of creative thinking required is significantly higher. These puzzles focus purely on logical reasoning and insight, reinforcing the idea that mathematical problem solving is not just about knowing formulas, but about how one approaches problem and generates new mathematical ideas. It's more about small c's that Boris reminded also, but it's still some creative process. Now, I'd like to illustrate one such puzzle, and I'll ask you to send the solutions by chat. Take 2-3 minutes. And here is the puzzle. I guess you can read the dialogue. And the question is, analyzing the dialogue, find out how old are the kids. could be challenging, especially for those of you that don't recognize it. It's unknown for him, not familiar with it. Have some good questions here in chat. I'm not sure that we have time to relate to all the suggestions, but by my feeling, it's very easy to engage students and also teachers and also mathematicians to challenge them with such kind of problems. I don't know what do you feel, but my experience usually in-service teachers and pre-service teachers they are engaged in solution such problems. Additionally, I'd like to say, do you want to know the answer, or you will stay under pressure? I just want to add that I tried this puzzle with ChatGPT, and it now is new aspects of research in math education with AI, and he suggests some answer. It was not correct. I gave to ChatGPT a tip or hint. It sent me another solution that it was also incorrect. After 7 rounds of tips and hints, finally I got the correct answer. So AI still is not so creative like we are. I still don't see the solution. Yeah, Marina asked me where the kids should be 5 years old or 6 years old. Let's say that they can be from 1 year old until 6 years old. I'd like to ask the research question, and probably Kitty and Ami, you will move to Viktor, and if people will ask the solution, I'll present it later. It's okay? Okay. So the research questions that I'd like to ask according to the puzzles is, what role do math puzzles play in developing creative thinking in general? And how do these specific types, I mean, these puzzles that have the cognitive gap between the mathematics that need to be used to solve it and the level of creative thinking. Here is my question, and Thank you very much.
So I would like to thanks to be with us. And what I was asked is to share some examples of mathematical problems that trigger creative approaches in primary middle school students. As you remember, Boris was working with quite advanced students with quite advanced mathematics and mathematical problems. My focus is on primary middle school, actually in Moncton, Francophone French sector I work at is key 8, it's called primary, so we don't have middle school. So I don't know, Kitty, if everyone had access to the problems or already solved them, or I just present them.
You can just present them, yes.
Okay, thank you. So yeah, what I planned to present was, yeah, I'm still struggling to get rid of the screen. Okay, now I think I got it. Okay, so the problems that I chose are coming from my past project, which is now only available as an archive, which some of you might have seen, which is called Kaye, Communauté d'apprentissage multidisciplinaire interactive. So it's a virtual community of problem solving, and it's homemade in French New Brunswick, Canada school system. It's really fruit of collaboration between the Université de Moncton and the school district. And in operation is from 2016. And as I said, now there is an archive with the link here. So more than 700 problems that were presented during this time using problem of the week model with examples of different solutions shared with the whole community. And actually, yeah, you need to get to this bank. You can just sign up for free. And the problems were split in 4 categories of difficulties and could be solved by any of Key 12 students individually or in a group. For each solution submitted, a personalized feedback was provided by pre-service teachers. So when you think about each problem, which I will show you, try to imagine how students without specific math knowledge would approach them. So can I move there? Yeah, okay. So this problem was published in 2010, and it is in French. As you see, this is how the screen looked. And that is in French, so I did a translation into English of the problem. And that was suggested because we have an option that any Kaye member of the virtual community could suggest a problem. This problem was suggested, but I don't have records by the student or by the teacher, by the class, I don't know. But it called wheels. Charles has a collection of several tricycles and a few bicycles. If it has 34 wheels in total, and Charles owns at least 5 tricycles, how many bicycles does he have? Don't forget to show your reasoning. That's how it was presented. I'm sure that with the short time I have, you don't quite have time to think about it, but what it would be your just, if someone can say, what is your first reaction to this problem? I would like to have some feedback from you. Just let you think a little. Yeah, Zach, I think.
Zach, maybe you can put your chat. Sorry.
Okay, thank you. Sorry, I forgot about that. My first reaction is one of the number of tricycles has to be even because there's an even number of wheels.
Yeah.
And then I think I have to try some numbers.
Okay. Thank you. Some other reactions? Some other reactions from someone else? So what would children do with that problem? What do you think? What strategies do you expect they would try? Okay, I don't know if there's someone writing on.
A few people said trial and error as a strategy,
Okay.
but they're a bit lost. Zach suggested they start with 5 tricycles, and again, I guess trial and error, play with the numbers.
Interesting. Okay, then let me show the second one. Yeah, the second example is also from Kaye, but that was analyzed in one of our chapters, book chapters in the book on mathematical creativity and technology. And still, I had colleagues like Xavier Bichot, who is a music educator. Yves is doing research on creativity with de Champlain, and Lucie de Blois, someone might know, is didactique des mathématiques. And this is a problem that you see on the screen. Sasha has 75 cents in her piggy bank. She has pennies, nickels, dimes, and quarters. How many coins of each type are in the piggy bank? It's, again, quite a known problem, but if you think that the Kaye members are mostly from the primary school, some from the high school, but again, even in the high school, our curriculum doesn't introduce that high level of mathematics that could be behind this task. So again, the same question that I asked you. I'll let you some few minutes to think. Someone would like to share the first thoughts? I think something is happening in the chat. Trial and error again, many possibilities. That's true. Interesting, that trial and error. That's what we need to discuss, of course. Yeah, that's great. Interesting. Other than trial and error, could it be any other strategies that children can employ? Yeah, that's interesting to see an equation. Can be, we know it can be. Yeah, that's also very interesting that someone thinks that what we cannot have. That's very interesting. Yeah, thank you. So now to wrap up my 10 minutes, hopefully I'm still within time, just to show that we were trying to determine some characteristics of Kaye problems that might spark students' creativity. So, for example, I had Dominique Manuel, someone might know him, who wrote a thesis investigating creativity in using Rosa Lakin's model of collective solution space, so taking all solutions and actually all problems that had more than a certain amount of solutions. I don't remember what he took as criteria. And then he investigated if a richer problem with characteristic of a richer problem that you see here, open-ended, multiple solution, multiple strategies, complex, no ready-to-use approach, ill-defined, contextualized, and object of multiple interpretation. So he analyzed with that framework like all problems which had a certain amount of solutions. And then he analyzed the creativity within some of them. He selected some, and then he was investigating for that sample if there is a connection between the problem to be reached according to that criteria and lead to more creative solutions. So then the last slide that Kaye had inspired French teachers to create a resource for teachers in France. As you see, this is CM1, CM2, 6, so which means grades 3 to which for grades 4 to 6 in Canada, but put it 6 to 8, considering, for example, the difference between the curriculum in New Brunswick, for example, and in France. So the problème à chercher, which is problems to investigate, low entry, high ceiling. So it can be tried by everyone, but it has potential to go to very deep mathematics. So that's what I wanted. And there is what the link I have. I don't know if you shared this PowerPoint, but there is a link to a free access to the this online resource. It's in French, and I created 45 challenging tasks. Yeah, and I see other comments coming and very interesting questions for discussion. So I will stop for now here. And I think, I don't know if I'm within time. I'm lost a bit, Amy.
It's okay,
anyway.
Viktor, thank you very much.
Yeah.
So now the four of you could react to the questions shared earlier. I have all the questions on in our slides deck, except Mark, I don't have yours. If our audience going to refer back to your question, you probably could re-sharing your screen for the question. So I will leave it here. If you need that particular question to talk about or to comment on, I will try to locate that particular problem for you.
There is already a reaction from Boris in the chat, so we'll just read it aloud. There are 3 different answers to the bicycle-tricycle problem. Is this the intention?
Well, that's a good question. The intention was actually to suggest a problem which would trigger some interest from people, because it's in an online environment. Unless the teacher uses it as mandatory task with the whole class, it could be done from different schools, from different by different children of different abilities. So that means what we wanted to trigger here is really not necessarily finding 3 different answers, but more trying to develop a process of how would you search for them? What is your approach? And here we expected that the children would use different approaches, which can be shared. And if you have this function of sharing and discussing, for example, in the classroom, it's interesting to discuss different approaches, but also try to reason. How would you reason to prove, for example, there are 3 different answers? Why there's no more? So that's to be very quick. That's what my first reaction. I don't know, Boris, would you like to react, explore? I don't know. Maybe other colleagues.
Boris, would you like to respond to that?
Oh, Viktor, just thank you for the explanation. I have nothing to add. I was just solving the problem, found 3 answers, but the problem formulation was hinting on 1 answer, but it depends on culture, how you ask questions, to explain your reasons. Nothing further to comment. Thank you.
Yeah, I would add another thing that might spark a discussion and some different reactions, because if you read again, and of course it's very difficult to make an exact translation, but having it in French, the way how you say I think it's said there are many tricycles and some bicycles. So that might have a discussion if you really have 3 solutions. How would you interpret that many and some? Just in addition to that. So in many tasks, we try to put that. For example, there is another problem that I liked also with also very known from mathematical point of view. When you have an amount of money and you buy flowers of each part, and what are different combinations of flowers you can find. Try to find all combinations, but as cerise sur le gâteau, as a cherry on the cake, is what would be your what would be the most beautiful combination? And that sparks well, that's unfortunately overlooked, this tiny that we thought that maybe some will say, okay, I want only roses. And then other would say, we want to have some balance. So what is the combination which has a balanced number of? So that's kind of new questions that children may ask if we go that far. And that's kind of tricks we try to put. Okay, then should I go to see other messages? Yeah, that's very interesting. I see the very interesting, yeah, the very interesting comment. Okay, no, am I losing that? Because I saw that, yeah, systematically trying and erroring. That's, yeah. We want to encourage to see how that students' creativity would led them to develop some more systematic way of looking for solutions. Absolutely, Jimmy, I agree with you. This structure resonates with what Demetra presented. Unfortunately, I was not there, but I know Demetra's work and see it very well. And I think it's absolutely important that reframe typical questions. I'm teaching this semester a MathEd course, and again, I'm trying to change this view of mathematics as looking for one answer or many answers, but all answers, but more focusing on students' original ideas, how they see that, what they're sensitive to. So I think that's a very good comment, Amy. And we know that, yeah, that's, I think I already commented. Is any approach to solving this problem creative? Well, Dragana, thank you for your comment. And you know how difficult it is to answer. The easy answer is yes. If we put creativity in terms of write something, but if we focus a little bit on some more plausible way of seeing mathematics, to trying to put some richer concepts into that and put the glasses, but that's very important. What kind of glasses would you put? And depending on that glasses, you will judge as a teacher what would be creative and wrong or completely wrong, and how a solution, and how this, or even wrong, incorrect strategy, and how would you organize the work of students to get a discussion around that and to try to change. But that's a very difficult question, Dragan, as you know. And Boris has answered, depending on whom and when, of course. Identify constraints, 1 to quarter. Yeah, absolutely. That's all good. Yeah.
So there has been a lot of chat happening during the panel, and I think people are very engaged, not only with the problems themselves, but the kind of application it can have into their own teaching, as well as the thinking processes. And for me, this idea of multiple solutions, multiple approaches, multiple possibilities has been kind of a common thread, as well as kind of an ambiguity or some level of uncertainty in the problem that needs negotiation. But this creates some challenges for teachers who are maybe used to interpreting the curriculum in more standard ways, who've compartmentalized curriculum. And so there are a lot of questions around realizing these in a classroom, but also with this notion of assessment. And Jimmy has asked several questions, but one of them to maybe bridge these ideas is his question: what might be the difference in seeing creativity in student strategies compared with seeing creativity in student solutions, and how do we value both? To anyone from this morning's talk, any of our speakers will be happy to hear from you.
Can I just answer, try and answer a little bit on this? I mean, these are the issues that have been puzzling us, both as teachers in the classroom as well as mathematics educational researchers. What I mean by that is, first of all, I think that we need to help teachers find ways to teach mathematical creativity and teach creativity in the classroom, because I have the impression that very often we may be educating our children out of their creative capacity in classroom. And we need to give opportunities. And there have been studies that have shown that although IQ may have been increasing or reaching a plateau, research on creativity has been showing that students' creativity is deteriorating. There are also studies that show that the creative abilities of 15-year-olds are lower than the 10-year-olds. So this is something that we are concerned about. So what I feel we need to do is that within the restrictions of the curriculum, because we know teachers are under pressure of time, creativity is not being assessed, and teachers are not trained on this. These are issues that are not helping us. So the suggestion on my side would be to try and find instances in our classroom, in our lessons, where we can make small modifications and address creativity, like by asking children to provide another answer, by asking them to talk about different strategies they've solved, by trying to leaving the problems a bit more ill-defined. And then again, we come to these issues, how do we assess these things? And we had a lot of problem in assessing creativity, not only in the classroom, but as researchers. And researchers have provided various answers. I mean, some people assess the fluency, the number of responses, the type of different responses, and people have tried to also give marks to how original and rare responses have been. It's not an easy task to do. It's time-consuming and quite complex. There have been various models on how one can measure these things, but as we say, the jury's still out. I mean, we still need more ideas on how to assess creativity. And there have been suggestions that you might be looking about rare responses, but also the complexity level of the response is not enough to be rare. It needs to have a certain level of complexity. So yes, we are all concerned of how do we assess it. The interesting thing and the optimistic side of things, I would say here is another thing. I've seen recently that at Tufts University, for example, since they started assessing creativity and having creativity tasks, more minority students have been able to enroll into the universities and get positions. So I think these are important issues that we need to work on. I've tried to sort of say a little bit about different things. I don't know if I answered the question, but these things, I think, are some of the issues that really are important to us as a community, as teachers and researchers.
Yeah, thank you. And I think there are some proxies that could confuse us that maybe aren't what we want to be thinking about when it comes to creativity and valuing that. So thank you for your response. Did anyone else want to add to it?
Well, just very quickly, a very short comment on it. We need to change a little bit the culture when mathematical problem needs to be solved quickly. Unfortunately, that's what we put, time limits and so on. But it's also developed this kind of taste of staying with the problem, trying to search for different possibilities. Okay, if we change that, if I know Boris spoke about it, I know your paper you presented, but what I'm saying, it's very important to develop this. So I can cite Linda Sheffield, for example, who wrote that our curriculum is mile large and inch deep. So we need to focus, and one problem might get access to a lot of concepts and a lot of things, and that's what teachers who do that. But very unfortunately, we have also issues, for example, of explicit teaching and putting pressure for, to make sure that all students succeed. But success is personal, as is creativity. So that means it's another thing. So giving time issue, because it's fast, okay, in 45 minutes is non-mathematics, let's move to Francais, then let's move to science. So look for more investigative, taste for, but that's a huge paradigm shift that is still in my dreams. Thanks.
Probably a sentence about it if we still have time.
Can we have Mark speak a little bit more about his task? Because I was curious about not the answer, how to approach it. Mark, are you still with us? Yep.
Yeah, I'm here. Do you want me to relate to some questions or to the problem I asked?
You can, either way, Is there anything you wanna tell us or share with us before we go?
Somebody asked about how can we assess creativity. It's I think that Boris also answered that it's a big question, and it's very difficult issue. And I think that we should try to answer, but it's very very difficult one. Somebody write that one an answer to the sans cats question. I'd like first to ask, could the number of cats be 5, for example? If the number of cats is 5, then the answer is that the sons are 1 year old and 5 years old. So it could not be 5, because if so, the man A, the first one, or 6, the second one, I don't remember, should give the answer. Then we are looking for the numbers that could have two cases, at least 2 cases of 2 different numbers, that the product is the number of the cats. We still need to take in account that the kids are not going to the schools, that their age could vary between 1 and 6. Let's say 6 includes 6. In some countries, I guess that 6 is, they still don't go to the school. Then after this, we can make a list of the possible numbers. And because he didn't answer after the first hint that the age product of the age is the number of the cat, and he gave the next tip or hint that the oldest son is like his mother, it means that it could not be twins. It could not be twins, so it should be 1 and 4, that the product is 4, and 2 and 2 is, we should erase this answer. So 1 and 4 is the answer. We need to check another possibilities, like 3 and 3, but the other one will be 1 and 9, and 9 is going to the school. And I think that it's enough to check, right? So the answer is 1 and 4.
Thank you. I think you put a lot of people's mind at ease now. They can resolve their uncertainty. One of the other threads that came through was this level of ambiguity in the problem, but also in the possibilities for students. So rare ideas, but also rare for them ideas. And the challenge that it creates for teachers' knowledge of mathematics, but also their pedagogy. And I suspect it requires a different release of maybe control. There was a comment there talking about maybe classroom management is more challenging when there's an invitation for creative and maybe unexpected solutions or strategies. I don't think I have a question there, I'm sorry, but maybe I will invite comment or reflection.
Shall I contribute? I don't want to monopolize the discussion. Yes. I mean, for sure, it's more challenging for teachers if we open up for more creative solutions and have more open solutions, and how they will assess it and how they will manage it in the classroom. And this is why I think I'm putting also the suggestion that it doesn't need necessarily to only be open problems or multiple solutions, but actually even to address closed questions, but the answer might be a creative one, or the children have to think in a creative way to reach their answer. For sure, for the multiple solutions or multiple answers, then we have to come up with some ways of assessing it. I probably mentioned it too briefly, but we can count how many responses, how many different responses, how many were rare, or give levels to which were more demanding or complex. And for sure, we need training for the teachers of how to approach this problem. And we can start small, let's say, and then build up. I think also another thing that is important, I think OECD, one of OECD's research showed is that we should engage in creativity, not every day, but a moderate use of creative tasks, not to the extreme of being rare, not be all the time, and always doing it, but to have some moderate use. And it's an interesting result that they found is that this is what I wanted to contribute. Yeah.
Thank you. Boris, I think you had a comment to make earlier, but didn't get the chance.
Well, nothing important, but the discussion is interesting. I think that one of the most solid findings in creativity research is that the teachers don't have time. And I think that it will not change easily. So I'd like to continue what Demetra began and to think about some optimal timeline of activities that supposedly develop creativity. Actually, the idea of flashes of creativity was to say that if you do it sometimes, it matters. It matters a lot because it creates memorable experiences. And in Israel, when in our professional development courses we hear that I don't have time for these wonderful activities, sometimes facilitators ask, okay, you don't have time at all, or you have time to do it once in a year, you have time to do it once in a month, and if you don't have time to do it at all, it is also a message. So the statements like, I don't have time, always has this underlying layer of preferences for what you do have time. And this is something that can be promoted in professional development courses with teachers, for example. Another comment I want to make about assessment, which is related here, because not only time, but I teach what is assessed. This is another very common view among teachers. And here we really face the problem of creativity assessment. For example, if I have a grade 87 out of 100 that assesses my knowledge, one can say that, okay, I am proficient in some portion, 87% of notions or ideas or material taught. But what is the meaning of I have a creativity grade of 87? I don't know. We don't have this perfectly defined field to measure in numbers, in grades, in order to value too much creativity assessment, at least in terms of standardized tests. But we have alternative ways of assessment. We have portfolio assessment, we have peer assessment, we have many, many other things. And somehow to say that I want my students to be creative, but I want to measure creativity not by means of standard, not creative tools, in my view, is problematic. So these two go together.
Thank you so much for those thoughts. We appreciate very much all of the great ideas and interesting discussion that came out. I think knowing this crowd, we could talk all day, but I want to respect people's time and commitment. We are now a little bit over time, so I think we should wrap up. Although these questions around different ways for bringing creative tasks or opportunities for creative experiences into our classroom, even if it is in small ways it's worth making time for and valuing. So thank you all so much for your presentations, your patience with us, and your resilience in sticking with us today.